Hi, welcome back. This is what I'm calling Tile Game Lesson 12 Part 2, since we kind of added in a little something outside of the plan when I answered a request to make a mouse look instead of rotating our position with the arrows. One thing I want to do before we finish Lesson 12 is I want to fix one issue with that mouse look. So if you... Actually, let me turn off the zombie speed. I don't want him in our way while we're doing this. So if you try and run towards your mouse, you can get this weird spinning sensation or back and forth sensation. Now, it doesn't seem to cause a problem once the camera starts to move, but when the camera's still, you get this very strange spin thing. And that's because once that player reaches the mouse, the player immediately tries to turn around and look at it again. So he's just caught in this back and forth of passing up your mouse and looking around it, like constantly missing your exit on a freeway and having to turn around. So let's make it to where he only moves if the mouse is a little bit of distance away from him. So that's really easy fix. Just go to Sprites, Player, Update, and right here on what is my line 64 is what moves the player. So I will say if. Now, the distance from my player to my mouse is really easy to calculate because we found a vector from our player's location after adjusted for the camera to our mouse earlier. I just need the length of that vector. And that is really easy to find. So a vector is, we can think of it as a set of instructions for moving from point A to point B. So for example, if our vector was 3, 4, that means go 3 to the right in the x direction and 4 up, which means that the total change in our position is 3 squared plus 4 squared is 5 squared. 3, 4, 5. This is a right triangle. In general, then if I have a vector, without knowing what its components are, the first component we call x, tells you how far to move left and right. The second component, y. So we can find this length as x squared plus y squared square rooted using the Pythagorean theorem. And that method is already included for us called length. But Pygame does not suggest we use this method because it's so slow. It has to take the square root of something, and the square root is a very slow operation. They say it's much faster if you leave this as just x squared plus y squared, and whatever distance you want to compare it to, square that. So I'm going to make sure that the mouse pointer is 5 pixels away, so I'll instead say 5 squared away. So we could just calculate it ourselves, but they have it for us. We take the look vect. Look vect is created by the distance from our self to the mouse pointer, and call length squared. And I want to say if that's bigger than 5, and I could call 5 squared 25, of course, but I feel like this will be more obvious that I'm looking for 5 pixels when I look at this code later. All right, so that's going to make it to where it doesn't run, it doesn't move when too close to the mouse. So once he gets that close to the mouse, he just stays still because he's reached it. So you need to move it further away. Okay, so quick little fix there. Let me turn back on the zombie speed, and I want you to see the next issue that we have to fix, which will be a small change. So this issue is actually related to the one we were just talking about. When that zombie reaches us, he continuously passes us up and then tries to do a quick 180 to look at us again. And so this is a really unrealistic kind of movement. The zombie movement in general is not very accurate. He also moves kind of like he's floating. He instantly starts moving instead of speeding up and slowing down. So we need to make our motion more realistic. And so we're going to do that by, instead of just using velocity and time and position, we're going to use acceleration, velocity, position, and time. Acceleration is the change in your velocity. So let's go over here, and instead of making our zombie speed, let's do zombie acceleration. Oh. in my zombie files. Oh, I lost something there. I'll set it to 150 pixels per second. So now I'm not setting the speed, I'm setting the amount that the zombie speeds up. Well, if I give an acceleration, that means that every second it's going 150 pixels faster per second than it was before. So we just be speeding up indefinitely. We need to put some sort of stop to that. And so we'll create a friction variable that kind of makes like a terminal velocity, like having a parachute on when you fall, slowing you down. So we'll use this friction to slow us down. And I just kind of played with that number, and that was the one that works. So now let's go to Sprites and go to Zombie, and we need to go to the init and change this from velocity to acceleration vector. And we are using our acceleration. And there we have it. And we'll go ahead and create a velocity as well. But we'll just leave that at 0 for now. And I'm going to call this the vectors for motion. So we've got a position, an acceleration, and a velocity. And now let's go down to update. But first, I want to talk a little bit about our motion equation. So when defining motion, realistically, we need to go back to our physics class. So what we know is that the change in position, now this triangle means delta, it means change in. Change in position is controlled by velocity. Let me come back to that. Change in velocity is acceleration. So our change in velocity is going to be our acceleration times the amount of time that's passed that we call delta time. Well, for us, we're just calling that dt. That's our delta time, which is usually around 7, 6, 7, or 8, because that's about how many milliseconds passes in between each frame. So to figure out your change in velocity, you take your rate of acceleration times the change in time. Now, to figure out your change in position, if your acceleration is 0, then it's simply velocity times delta time. But if you're experiencing acceleration as well, it turns out that acceleration is also affecting it. So the formula is 1/2 acceleration times delta time squared plus velocity times delta time. And for us, we're not going to be writing delta p. We're going to be saying our change in position by using plus equals and our change in velocity by using plus equals. So take a look at how we code that in. So instead of making this new vector each time for velocity, again, I'm in the update method in the Sprites module for zombie. We're going to say self.acceleration, and we'll simply rotate this vector the amount of our angle that we calculated earlier. Now we'll use that to make a change in our velocity. So we'll say self.velocity is equal to acceleration times the change in velocity is equal to our acceleration times the change in time. Self.acceleration times self.gain.dt is our delta time. This is one of the cool things about vectors. It turns out there's an x component to our acceleration and a y component, just like there's an x component and a y component of velocity. This handles both. All right, and now we have our self.position. Well, we need to add to this the acceleration portion. So we'll say 1/2 times self.acceleration times self.gain.delta time, and there's me squaring it. So now this is our full position. So we'll remove position by velocity and acceleration. And that's a very important formula to know. All right, there is one more thing we need to do. We made a friction constant, but we need to use it to slow down our zombie. So what I'm going to do is I'm going to take this acceleration, and before we apply it to velocity, we're going to adjust it. So we'll say self.acceleration decreases by self.velocity times zombie friction. So basically what that means is the faster our zombie goes, the more the acceleration is decreased until that acceleration becomes basically zero. And so let's save that and see what happens now. All right, so the zombie comes towards us and then, slows down and tries to circle back around. So it's definitely better. I feel like it's a little too loose right now with the friction. Maybe make that friction a little bit higher and maybe even slow down the zombie, but we'll wait and see. And of course, having collisions will affect it as well. So I don't want to go too far into this, but we can see the zombie is chasing us. When he passes us, he slows down and tries to come back. All right, sounds good. All right, so we'll call that part done, and we'll move on to making the zombie hit a wall and stop. So to make the zombie work, we could, take and, we need to have the collisions. We could take the player's method for check for collisions, and we could just copy all that and use it again for our zombie. And I think that would work pretty well. But we could also just take this and make it a function based on we could take this and make it a function that checks for any kind of collisions for a given sprite and sprite group. So I think that's what we should do. So we're going to take this check for collisions and we're going to remove it from our player class. So it's Control X because I'm going to use it. So it's gone. It's no longer in the player class. And we're going to make it a function that is attached to the sprite module that is not in the player class. So I just pasted it, and I'll have to highlight all of this and hit Shift Tab to move that all over a line. Okay, so we can't use self anymore because we're not inside the class, but we're going to say sprite, and this will give us sprite group and direction. So first we have to get all of our I'm not going to call them wall collisions. I'll just call it collisions now. So we're going to sprite collide with the sprite. It's not formatting quite right. Let me see. It should go right underneath. There we go. All right. And we can't say self anymore because we're not inside a class, but we're going to use the sprite group that we were passed as a parameter. And false, we don't want anything destroyed, and we will continue to use the hitbox collide. We're going to use that for both zombies and ourselves. So now all these self.vel x's is going to have to become sprite. Sprite.velocityx. And this will be sprite.position. So I'm just going to copy and paste sprite here. There we go. And wall collisions, not really a wall. It's just a collision. So I'll just call this. Well, let's see, obstacle. And we're getting the first obstacle from our wall collisions. All right. And so obstacle, obstacle. And that looks pretty good. Now we just need to do the same thing for the y direction. So again, we're going to call this collisions so that we don't have to think about it as just being a wall collision. We're going to be looking for collisions between the sprite parameter, the sprite group parameter. We'll be using, we will not be destroying the objects that collide, and we'll be using hitbox collide. If the number of collisions is greater than 0, and again, I'm going to just change this from wall to obstacle. And I'll quickly change the two walls to obstacle. And self needs to become sprite, because we are not calling it on ourselves, we're calling it on the sprite. Whatever sprite we pass it. Now, when you're doing something like this, don't be surprised if you miss a self or something like that and have errors, have to come back and fix it. But that's normal. It's hard to, everybody makes mistakes, and hopefully I didn't make a mistake here and executed this correctly, but we'll find out. All right, so that looks better. Okay, I think all that is pretty much done. So now we've got a function that we can use and call. So we need to fix our player, because currently in our update we have self.check for collisions. Well, that's not okay anymore because it's not in the class. It's a function, so we can't do that. Well, to call the function inside our module, we just remove the word self. But then we've got to put self as our parameter here. And self.game.wall group is what we are looking for collisions with. But I like this because you'll be able to use that collision algorithm that we just wrote. We can add that in any function in any game that you write. All right, so let me just copy and paste that because I'm going to be using it a couple of times. The only difference is I change that to y. All right, super cool. Now we just basically do the exact same thing for zombie. So let's go down to our zombie method. And after we change our position, we're going to say self.hitboxRect.centerX equals our position x. So our hitbox, we're going to change one component at a time. So again, that's the beauty of vector. It's got an x component and a y component. We can break it down. So that way, if the zombie collides with the wall, it can still keep sliding in the y direction. So then we call our check for collisions. I've got it right there. Self now is not the player. Self is the zombie because we're in the zombie class. And that's perfect. After moving, we then need to reposition our hitbox. You remember doing this before with the player. So we go ahead and move the hitbox, and then we let the position get adjusted as necessary for hitting a wall, and then we reassign our hitbox to that new position. So it's, we're not actually moving, we're like virtually moving, checking for collisions with that move of the hitbox, and then finalize it. So that's why it looks like we're doing the same thing twice. All right, we're just going to do this exact same thing again, but we'll do it in the y direction. So we're going to move the center y. And there we have it. So let's try running it. Sprite group is not defined. Hold on, I've got an error, I'm afraid. Sprite group is right there. Why are you... Oh, misspelled it. Misspelled right up there? Okay. All right, so let's take a look at this variable. And it looks like the zombie does not want to run through me. So that's good. Although I'm having a bit of trouble with that mouse issue that we have. I keep forgetting that I can't touch the mouse. All right. So yeah, the zombie definitely has to avoid walls now. It could still run through us, but we're going to make that to where it actually takes away our health here in a bit. So that looks pretty good. And okay, so I think that's it for this lesson. I'll see you in lesson 13.